So, dehydrohalogenation is the conversion of an alkyl halide to an alkene using a strong base. It's an elimination reaction because we are taking elements out of a molecule without replacing them with any other elements. We're going to go through an example where we discuss the mechanism of how it happens, as well as the how to choose different products, or how to predict the major product, and if we have time, perhaps a little stereochemistry. Looking at the example at hand, we have an alkyl halide 2-bromobutane. In this elimination reaction, we are going to eliminate the bromine as a leaving group, and from a carbon that is adjacent to the bromine, which means we're choosing between the purple carbon here and the green carbon here, we're going to take away a hydrogen. So dehydrohalogenation is the removal, D, of a hydrogen, hydro, and a halogen. Right? So dehydrohalogenation, removal of a hydrogen and a halogen. And again, those two atoms have to come off adjacent carbons, because then we're making room on each carbon for the pi bond in the alkene. When we do this as a mechanism, it will always follow the E2 mechanism. And anytime we're using a strong base, that's going to be the case. And in this case, in the E2 mechanism, everything happens at once. So we consider our two choices, either one of the purple hydrogens on the left or one of the green hydrogens on the right. Notice that if we choose one of the green hydrogens, and we'll go through that mechanism, we take a lone pair from the oxygen, it makes a bond to the hydrogen. That means that this is in fact acting like a base because it's picking up a hydrogen. We're going to use the carbon-hydrogen sigma bond. The pair of electrons from that will become the carbon-carbon pi bond, and then we will eject or kick out our leaving group. So we have a concerted mechanism. Everything happens at once. And we say, of course, SN2 and E2 are bimolecular, and that everything happens at once. This particular step then will give us the product in which the double bond is located between the two center carbons. So abandoning our color schemes, that will give us this alkene. Notice that we have drawn the trans isomer because that's the most stable isomer. When we're choosing products, we want to choose the more highly substituted alkene product, and then we typically will favor trans over cis. In this particular case, however, we will also expect to see some of the cis product. It will simply be a minor product, whereas our major product will be the more stable alkene. If we had instead picked one of the purple hydrogens, we would make the double bond between the number 1 and the number 2 carbons, and we would end up with 1 butene. And we would expect to see some of this product as well, but again, as another minor product.